Hi everyone, my name is Deborah Fowler and I'm going to talk about loops in the context of Python and Turtle graphics. So let's start off by bringing up idle, which comes with Python. And this is just a convenient way of creating Python files. This is an interactive shell. I'm going to say new file and I'm just going to do the classic hello world. If you've already done the introduction or watched the introduction that I have to Turtle graphics, this might be a little redundant, but bear with me. I just want to show you one other thing. So let's do snowman.py. And you can see it prints hello world. So it has nothing to do with snowman, but it doesn't matter what I call it. It's just executing whatever is inside here. Let's go ahead and import turtle. And I'm going to save myself some typing and set turtle T. So if I now say turtle.forward, it's going to create a Tkinter window. And that's my graphics window that's going to draw on, and it's going to draw a line moving forward. In the default, it starts at the center, it's facing towards the positive x-axis, and it's moving that line. Okay. So it draws that line. Let's instead draw a circle. All right, so here we have our circle. Now, if we want to draw a circle on top of each other, we need to set that turtle position to be at the top of this circle. So there's two ways to do that. We could either do a forward command, or we could do a set position. Let's show both. So turtle.forward 100, well, that's not going to work because it's going to go in the direction that the turtle's facing. So we have to turn the turtle to be facing up. We're going to go forward, and then we're going to set the default position of facing 0 degrees, and then we're going to draw another circle. Okay, now one thing we want to do is pick up our pen. So whenever you see a forward or a set position that you are just resetting the position of the turtle and you're not intending to draw, you want to surround it with pen up, move it, pen down, then draw. So let's go ahead and look at that. And you can see that it's drawing a circle, and then it goes and moves the turtle and goes up. And we forgot to multiply the radius by 2. So let's go ahead and do that. Because this is a radius and this is a diameter, we want to move to the top of the circle, so that will be its diameter. So now we have two snowballs. Now we're getting a little close to the top here, so we probably want to do something about that. So let's add a variable somewhere where you store information, and let's set that to the start position. So what I could do is I could move the turtle there. I could either do it forward, or I can do having to turn it, or I could do a set position. Let's try a set position for this part. So I'm going to say set position, and I'm going to do 0 and say start position. So what that does is it leaves the turtle in that position, and again, since I don't want it to draw when it's going there, I'm going to pick up the pen and then put it back down. Okay, so I run this, and I've got my turtle who goes down to the bottom, draws a circle, goes back up to relative where it is, it goes forward 100. Okay. Now, I don't necessarily have to use forward. I could have also used set position here. Let's see what that looks like. So if I get rid of left, and I don't need to reset the heading now, what I've got is this in here. We're going to set position, but we don't want 0 to 100 because that's going to be a specific position. What we want is it to be relative to that start position. So we're going to add 200 units. So wherever it was, plus 200 units. So if we run this, you can see what we get is it goes to the bottom, starts, and then we draw our other circle. Okay, so that's looking pretty good. We want to do a third one. So another way to do a third one would be to do the same kind of thing. So we grab this, we got our first circle, got our next circle, and probably a good idea to do a little spacing to keep this clear. Whoopsie, what we're doing. Okay, so first circle, second circle, third circle. So now we don't want to just go up by 200 units. We want to go by 200 units in the next circle, right? So we can see that we've got a circle and another circle and another circle. Okay, so what we can do is we can make this a little cleaner. Right now we've got 3 circles. We're basically repeating our code. And all this is doing is the number of circles that are before it are multiplied by the diameter of that circle. So we go start position plus 200, position plus 200 plus 200. If we did another one, be the same thing. So let's get rid of some of this code and be more efficient by creating a for loop. So we're going to get rid of that redundant code, and I'm going to say in range 0 through 3, go ahead and set your position to the start position, but then you're going to add in the radius of the number of circles times I. So however many circles you've gone through, you're going to add that position. So if it's 0, it'll add 0 to the start position. If it's 1, it'll add 200. If it's 2, it'll add 400, and so on. So this becomes exactly what you need. Remember that Python does block by indenting, so it knows the range of this for each. And we're going to run that. And we can see that it goes down to the bottom, draws one circle, goes to the next, and to the next. Well, it's not looking very much like a snowman, so let's actually try to shrink it. Well, if we shrink the circle, let's say we take and define the snowball radius. So let's call it size. And let's go ahead and change this. That's going to give us the same thing. But what if we shrink the snowball size each time? So let's multiply that each time by 0.7. So what this really means, whenever you see the shortcut, is snowball size equals snowball size, so whatever the variable name is, times whatever the value. Okay, so this is just a shorter way, it's a shortcut to write that same thing. Okay, so let's go ahead and run this. This is not going to work yet because we haven't set up this to take into account the snowball size. So let's go ahead and run this. And you can see that it draws our little snowballs, but that last one is wrong because it's assuming that it's going to be 200 units, and it's going to keep on doing that. So what we want to do is not have this being everyone is 200. We want it to be the current snowball size. So we want to keep track of that. Well, we're doing that right here. So what we're going to do is go ahead, call this snowball size. But if we just multiply by I, well, each snowball size isn't the same. So how's that going to work? Okay, so what we need to do is keep track of the current position. So instead of this, what we're going to do is change this to current position. And in here, what we're going to do is we're going to add the snowball size to the current position. So after we've drawn it, we set the turtle to be able to get to the next position by keeping track of it. So we're going to add the snowball size times 2, because remember it's a radius. So whatever its current position is, when it gets ready for the next draw, it's going to add the snowball that we just drew. So let's go ahead and run that. Oops, we forgot to set the current position. So let's set current position to be equal to the start position. Okay, so let's go ahead and do that. You can see here what it does is it goes down to the start position, then it draws based on whatever the previous radiuses or diameters were. So it goes to here, it draws that first one, so it goes down to the bottom level, the start position, draws, then it goes up the snowball radius and draws this, and then it adds that size to the next one, and then it goes this and adds that size to the next one, and so on. So if we repeated this, say 5 times, it still works. And now one trick that I want to show you with Turtle is that if you turn the speed to 0, it's actually the fastest it can go. So up here at the top, we're going to set Turtle speed to equal to 0. And then we're going to go ahead and run this. So you can see it's very fast. Okay, so now we have a much more interesting snowman because we can make it however many snowballs we want. We can change that shrink factor in whatever way we want. So for example, maybe we think that that doesn't look quite right and we want to make it a little bit larger. Okay. And maybe we want to move that start position down a little further. So you can see here what we're getting is essentially a procedural way of creating a snowman in Python. We should probably take that comment out or change it to reflect what the actual statement is, but you can see here what we're doing is creating a loop to repeat a bunch of circle draws. That's all we're doing. So that's a better way to build a snowman. I hope that was useful. Another thing we could do is we could also call this, it's called the shrink factor, just to make it easier for the person who might want to use this tool so that they can easily change it. We could also make these values input from a user. We'll get into that at another time. Okay, so I hope you've enjoyed this. That's how to build a snowman.